Greetings, this is Chemistry with Nav. In this video we're going to take a look at atom economy and percentage yield, starting here with percentage yield. So percentage yield is really a measure of how much you've actually collected as compared to what you should have collected. So one way of thinking about this might be like a test result or an exam result. Your theoretical yield, of course, is 100%, but how much did you actually get? So if your test is, let's say, out of 37, and you managed to get 30 out of 37, your theoretical maximum is 37, your actual score was 30, therefore your percentage yield is going to be 30 divided by 37, times it by 100%, and you get your percentage. So that's all we're going to end up doing here. So the actual yield is usually from the question. Whereas the theoretical yield is probably going to have to come from a mole calculation. Because if you're told that you start off with a certain amount of nitrogen in the Haber process, then you can work out how much ammonia you ought to make. And then the question will say, well, you actually only made this much, so what's your percentage yield? But we'll look at an example in a moment. So this is just looking at how much you've actually collected compared to how much you should have collected. Atom economy is a little different. It's to do with the wastefulness of your process. So the percentage atom economy is calculated as the relative molecular mass of the desired product divided by the relative molecular mass of all the products. So everything that you make on the right hand side, again times 100%. So this is a bit like if you order a memory stick from Amazon. They send it to you in an enormous package, but actually all of that packaging has to be thrown away or recycled. It's not actually useful. The only bit that was useful was the tiny memory stick that came in the giant box. So your desired product is the very small memory stick, whereas the entirety of everything that came along is all the products, so the packaging as well as the actual item that you wanted. So this tells you as a percentage how much is useful, and so therefore we want to have atom economies which are very high so that we don't have a great deal of waste. If you have an addition reaction, you sometimes get asked in exams what is an addition reaction, or asked to define it. So this is where two or more products, or even reactants, two or more reactants combine to form one product. So that means that the percentage atom economy must always be 100%. So an example of that is ethene, C2H4, reacting with bromine, Br2, because you end up with 1,2-dibromoethane. That's the only product, and if there is only one product, then you must have 100% atom economy. So addition reactions are good in terms of atom economy. Let's just look at a little example. So in this example, 0.375 grams of CH3Br reacts with an excess of NaOH. According to the reaction, CH3Br plus NaOH goes to CH3OH, which is methanol, and NaBr. 0.103 grams of CH3OH is produced. Find the percentage yield. Also calculate the percentage atom economy of the process. Okay, so we've got two main targets here, but this is probably going to be a 4, maybe 5 mark question, but based on how much work we have to do. So we're going to start off with looking at the mass and the MR of anything that's actually useful in this question. So starting at the top, 0.375 grams of the CH3Br. So that goes in here. And we're going to have to start by doing a mole calculation to work out how much methanol we ought to make. So I'm going to put my question mark in here. The MR of CH3Br is going to be 12 plus 3 plus 79.9, and that ends up as 94.9. Now, we need to come down to moles, and moles is equal to mass over mR, so it's 0.375 over 94.9, gives me 3.97 times 10 to the minus 3 moles. We apply the mole ratio, which is 1 to 1, based on a 1 in front of each of those species, which means that we also have 3.97 times 10 to the minus 3 moles on the right hand side. The MR of methanol is 32, which is 12 plus 4 plus 16, 4 hydrogens in there in total. So now when I go back up, I can work out my mass as being the number of moles times the MR. So 3.97 times 10 to the minus 3 times 32, and that gives me 0.127 grams. So that's my theoretical maximum, and in the question it says that actually only 1.03 grams was produced. So my percentage yield is equal to 0.103, because that's my actual mass, and my theoretical maximum mass is 127 multiplied by 100% is equal to 81.0. So we had the 103 given to us in the question, saying that's what's actually produced. We had to calculate the 0.127 from the mole calculation. Now, the percentage atom economy is going to be equal to 32, because that's the desired product, the methanol, over 32 plus, now the sodium bromide is also a product, so we have to add up 23 and 79.9, and that's equal to 102.9, so that goes in there. That's just the methanol, so that's a combination of both of them on the bottom, and the methanol is the desired product on the top. Multiply this by 100%, gives me 23.7%. So we can see that the percentage yield is quite high in this process. That's good, it means there's not a lot lost in transfer, but we can see the atom economy is very low, which means that 3/4 of all of the products made actually have to be thrown away. So in terms of sustainability, we're going to want to find a use for that sodium bromide so that we're not actually wasting it.